Dear colleagues, now I would like to give a presentation about nature-based solutions in restoring a water body in an urban environment. So the official title is Rehabilitation of a former Danubian sidearm in the city of Vienna for recreational purposes. And it's a work which has been done by my colleague Mr. Fürst and myself. So the problem, before we do something, we should have first a problem. So there is a former large oxbow lake which served for more than 100 years for water-based recreation in the city of Vienna, quite close to the city center. And during the last decades, they modified the hydrological regime, etc. And suddenly, within a short period in the 1990s, the system collapsed. And it took about 15 years to bring it back to its former natural state. And somehow, I could say different measures were tried. But finally, those solutions close to nature, trying to re-establish former hydrological conditions, performed quite well. So the objective of my presentation, we have modified this water body quite strongly from its natural state into a very artificial state. And it worked pretty long time, but somehow we exceeded the tipping point, and then the system did not work at all. People complained, etc. So this contribution tries to demonstrate how green measures could help in water management. And I spoke so far what has happened, so I will give a brief summary of the history of our water bodies in the vicinity of the city of Vienna. So here you see the changes of the surface water system from 1570 on the left up to the situation of 1912. It's not the end. To describe that, on the left side, here is the city of Vienna. It was a small city in that time. And you see here the Danube River with many side arms, with many islands, and this was somehow the main river course here. It was very dynamic, so about 150 years later it looked differently, but the structure, a braiding river system, a gravel bed dominated river with many islands, is quite similar. Then, due to frequent inundation and mainly due to difficulties for navigation, they started step by step to develop navigation, and this required changes in the riverbed. So 1849, you see already here is a major arm of the Danube. Many of the side arms have already disappeared, but still quite dynamic river system, and it was decided to channelize the river. And this happened in the 1870s, and here you see the result. So the former braiding system with many side arms has been put into one straight channel. And what we analyze here is this former oxbow lake, this water body. You can see it in all the maps. And this water body has been completely cut off from the Danube. There was no direct link. And it was used step by step for recreational purposes. So per year, about 500,000 people and more used this area. You can rent a boat. There's a lot of restaurants there in the region. So you see how it looked like. And it's very close to the city center, so by metro it takes maybe 8 minutes to reach that area. But the modifications of the river system have not yet stopped. So in 1970s, it was felt that the flood protection of the city of Vienna is not sufficient anymore, and they built a bypass channel, as you can see here, which is only in use during flood events. So they open the gates here and release the flood water also through this bypass channel. A big island in between the Danube and the new bypass channel was formed, which is also used for water-based recreation. 20 years later, it was decided to build here, in the city of Vienna, a hydropower scheme. Hydropower requires that you have on both sides embankment dams, that you raise the water level, and this means you change the boundary conditions for the groundwater regime, which supplied water to this former oxbow lake. Not enough with that. Over a period of 20 years, an underground highway has here built, and many works have been done to seal the underground. And this means the interaction between former surface water system and the separated oxbow lake was more or less stopped. You can see that in this graph here. So you see a period of, for let's say 1975 to about 2012-14, and you see the average water table in these oxbow lake, and you can also here, indicated by the white area, conclude how strongly it variated. So the water table was sometimes quite high, and then it went down to about, by range was about 2 meters. So the water table of these cut-off oxbow lake was ranging by about 2 meters within a year. Without going into detail, without developing a model, what would you conclude? You see the dynamics of the surface water system was drastically reduced, and the variability of the water table was also drastically reduced. So from a dynamic water system, it turned into something like a bathing tube. And the bathing tube needs to be cleaned from time to time. And here the problem started in the late 1980s, early 1990s. We had not only a change in the hydrological system, we had also a change in the water balance. So we developed a groundwater model, and we modeled the interaction between surface and groundwater system. And here you see how the water balance and how the dynamics also in recharge has changed. So in the 1970s, most of the underground water came here in the upstream part and recharged the water body. And here it discharged again to the hinterland and to the Danube River. So feeding was in the upstream part, release in the downstream part. So it was not really a dynamic oxbow lake, but it has still some features of an oxbow lake, flow direction from upstream to downstream, and quite an intensive recharge. 20 years later, you see the discharge was drastically reduced, and they tried, due to the sealing, underground sealing works, and so it was tried to recharge it artificially with surface water here from the Danube to recharge this water lake, and they turned the direction from downstream to upstream. So a completely different system. Within a short period, the water body turned into a hypertrophic state, and here you see the situation, algae blooming, and it could not be used for swimming anymore. So they tried different measures to rehabilitate it, and it looked really ugly, and the whole fish population died, and it was in a horrible state. Now research started, took pretty long time to get some contracts, and limnologists and hydrologists worked on the topic, and the conclusions with respect to hydrology were: the groundwater dynamics has been reduced by about 50%, the underground recharge has been drastically reduced even by 80%, low water tables in springtime, as they were before, were missing, so it was always a filled water body. The groundwater input had a very low phosphorus content. The surface water input, which was used in the early 1990s, exhibited a higher phosphorus content. And the whole system went from a macrophyte-dominated lake to an algae-dominated lake. This was the previous situation. A lot of macrophytes which had to be harvested from time to time, and then visible depth was about 10 centimeters, a turbid algae-dominated water body. Okay? We estimated the annual phosphorus load before was about 60 kilogram per year, you see, PO4 phosphate. And it was small compared to the phosphate concentrated in the macrophytes. It was estimated by others that this would be about 700 tons of dry weight of macrophytes containing about 900 kilogram of phosphate. Means the ratio is about 1 to 15. Later on, the phosphate input was in the same range, even sometimes smaller, 3 to 60 kilogram. But due to the disappearance of the macrophytes, all the phosphate was released to the water body. And this means the system had no buffering capacity anymore. The variability of the water table, why is it important? In early spring, when vegetation period starts, the water table was very low. So macrophytes developed in that area where light could penetrate still to the ground, and with increasing water table, also the macrophyte dominated area became larger and larger. So we had large areas of macrophytes. The high water table reduced the macrophyte area substantially, and this also contributed to release of phosphate. Then, next thing, they started the chemotherapy, and they put iron chloride to reduce the nutrient concentration. It looked horrible. You can see here a boat which releases iron chloride, and they put also calcium nitrate, etc., to see if the water quality would improve. Next step, they said, well, we don't have enough oxygen, so they tried artificially with several of these kind of turbines to re-aerate the water body. It did not work. Then they tried biomanipulation, replanting of macrophytes artificially, etc. But the turbidity of the water did not ensure the survival of the macrophytes. Then they started water bird management, etc. Water bird management helped a little bit. Later on, it was decided to harvest permanently the macrophytes and to change the water management system. So to recharge the water body again via underground water, now it's artificial, or to have here something like an artificial wetland, where surface water from the Danube is released to this wetland, and via the underground, as you can see here on the right side, it penetrates through this bottom layers to deeper zones where it can be abstracted, and most of the phosphorus and nitrate is being collected here. As a result, we see here the dark line, the bold dark line indicates the macrophyte density. And you can see here, late 1980s, it dropped dramatically. Then, until the year 2000, it was very low, and then it developed again, and now it's again at a quite high level. So mostly by changing the recharge of the system, by creating artificial wetlands, and by trying to re-establish a macrophyte system instead of an algae control system. So we can conclude the water level changes were constituting a disadvantage for the whole system, but later on it was not possible to re-establish the very low level as it was before due to other constraints, technical constraints, but it is possible to lower it again in springtime and to recharge the whole system via an artificial wetland with low phosphate concentration water coming from this artificial wetland. Since about 2005, the water body is quite similar as it was decades before. And since that time, and this is about 15 years, the system is quite stable. Even in hot summer periods, it's able to cope with these extreme conditions quite well. And here are some references in English if someone is interested in that study. Would also like to refer to the book of Dokulil, which was recently published addressing this topic. I would like to thank you very much for your attention.